So yeah, thanks everybody for coming to the Quantum Mini Symposium at JuliaCon this year. I'm Catherine, I'm one of the organizers. There's a couple other organizers here. Michael, who's in the front here, please stand up and say hi. Roger, who's further back there. Ash, who was just up and sat down. And we've had a couple other people helping out. So if you have any questions or want to complain about something, please come talk to one of us. Another quick thing, especially if you're a presenter, so the default is going to be to record these talks, but if you'd like your talk not to be recorded, just please let us know. We'll ask the AV person to not record. Similarly, if you don't want to be photographed and you didn't get a don't photograph me lanyard, just let us know and we'll ask you to not get photographed. So we put this mini symposium together to try and kind of unite the various people in the quantum community in Julia World. One thing that I've noticed, and maybe other people have, like giving talks over the years at JuliaCon, is that it's kind of hard to do because for a general audience, you have to spend the first 2/3 of your talk just like motivating what is quantum mechanics or what is quantum computing. And so it's a little difficult to give a talk that's like both technically interesting and accessible to a general audience. So the goal of this mini was both to sort of have connections between people who are working in various aspects of quantum, like very broadly defined condensed matter, quantum chemistry, quantum computing, and then also give people space to sort of fully explore what they're doing in Julia without having to spend the first 20 minutes being like, this is a wave function. I mean, wave functions are great, but we don't necessarily need a huge number of introductory talks. So we tried to balance the content of the mini through a bunch of different areas, and you'll also see that tomorrow there's a bunch of other quantum talks that were submitted totally independently, which is awesome. We definitely encourage you to go to those. So we'll be in this room for the entire mini, which is split over the lunch period. So we'll have a few talks ending with mine right before lunch. Then we go for a 90-minute lunch. And definitely we encourage everybody to kind of sit together for that if you want to chat and discuss. Then in the afternoon, we have more talks, kind of a BOF discussion about tooling in the Julia language, changes, maybe common areas of interest for people to work together. And then after this mini ends, and I think it's one of the later ending tracks today. There's the poster session, which people should also definitely go to because there's a couple quantum talks there. Yeah, so that was a lot of information very fast. I actually didn't have like a huge script ready to say, so maybe one other thing I think we should just like kind of keep in mind during the mini is if you see somebody else here is working on something that you're working on, even if you're not giving a talk about it, please keep it in mind to discuss during the BOF, which we deliberately put at the end of the session, so we'll have lots to talk about. And then one other quick organizational thing, especially for speakers. So Michael and I are chairing the session, which means we will warn you when you have 5 minutes and probably like 1 minute left in your talk. Please don't go over that because we want to keep time for everybody and we want to have time for questions. And then similarly for everybody in the audience, if you want to ask a question, especially if the talk is being recorded, please wait for one of us to give you the microphone so that the AV is going to pick it up. Or if for some reason that doesn't happen, like I just faint and forget to do it, if you're the speaker, please repeat the question into the microphone so that it'll be audible on the AV. Any other quick organizational things? Yeah, we have a dongle up here for you to connect your laptop to. Again, if something is going wrong, just please let us know ASAP. There's a power outlet there for speakers. I don't know if there's a lot of power throughout the room for people who aren't speakers. Sorry about that. There's washrooms out and around for all genders if you need the washroom. And I think that's about everything, right? Is there anything else we needed to go over? Cool. All right, so that was very fast. I've had a lot of coffee this morning, as you can probably tell. And I've been up early. So since we have 5 minutes before the first talk, and John, are you here yet? There, okay, beautiful. So our first speaker has arrived. Ash is off the hook for another 30 minutes. So I just also then, since we do have a little bit of time, just wanted to do a quick poll maybe of the room. So who here is either like still a graduate student, undergrad, maybe high school? Anybody? Damn. All right, well, a lot of youngins in this room. Stop that. Who here is maybe like a postdoc, professor, still in academia? Also a lot of folks. Also National Lab, that counts too. And then who here is maybe in the quantum industry, like more broadly defined? few people. Okay, so those of us in the minority, please be gentle. And how many people here have either written or contributed to a package in the Julia Quantum world? Around? Okay, also a lot of people. Very cool. And who here has contributed to base Julia itself? Nice. Okay, and then this is also a sort of a starting question for the BOF. Who here has something they don't like about base Julia they want to complain about at the BOF, if anybody? All right, so just keep in mind those things, and we'll have plenty of time to discuss them later. And Michael, did you have anything you wanted to say since I totally dominated this?
Maybe you can ask about subjects. Yeah, then since we are pretty interdisciplinary, as Catherine said, maybe another question is what are sort of the subject backgrounds? So who identifies more as a physicist? Who is more in the direction of like chemistry, quantum chemistry? Anyone in the audience? Ah, so maybe that's just me then. So yeah, that. Sorry. Yeah, I'm talking about the science side. Exactly. Yeah. Yeah, exactly. That would be maybe the next question. Who doesn't feel like a scientist? More like software writer, software engineer. A few. Like research software engineer. Great. Anything else one can ask? Who doesn't feel identified by any of the things that I just said? Yeah. What like maybe you shout out what you feel like. Mathematicians. Okay. So who is a mathematician? Maybe hands up there. Just one. Okay. So who else? You also raised a hand. Robotics. Okay. Cool. That's an odd one out, I think. Right? Anyone else who feels like robotics? Yes, two. Wow. Interesting. I would have not expected that. Anyone else that I missed? Yeah. So what's your subject?
Energy, and we have an applied math research program, and we're looking at getting into quantum computing.
Applied math research program. Okay. Yeah. Yes. What's
Engineer.
engineers? Yes, sure. We have engineers. So I guess that's also a little bit in this direction. So who self-identifies as engineers? So yeah. Okay. Cool. Right. I think that pretty much covers it. Yes. So we basically just John. Yeah. Please go ahead and set up. You want to do it?
And I'll just reiterate while John is setting up. Thanks again for coming. And any faults in the organization of this are definitely on us. So blame us, not the speakers.
Because it's only 10 minutes, I'd love to walk around, but I think I'm probably just going to end up standing right in front of it. I'll probably, this is more, I prefer that if I do it. Thanks. Let's see. Actually, I think it's safest. I might be one of those bobbers and weavers, so this might be safe. And then I think I need to open up my the app thing that sends the signal or something.
I think they're covering that in terms of the.
Oh, I mean to get it out of here.
Oh, I see. So you need to.
Yeah, it's not. Let's see, HDMI. And then I need to set. I guess the resolution is normally. Yeah.
Nothing. Okay. So
Well, let me try it. Let me try that and see what happens.
I'm gonna have to do this like
It's typically, that's a standard. Let's see what happens. No, see, that's gonna happen.
it's not. I'm not sure if I can get it.
Yeah, see, it's very, yeah, but it's like, there's tiny portions.
I'm gonna try to keep the thing going in the record.
Let's see what's happening.
Not yet. Okay, but you need to see good at it. Yeah.
Yeah, let's see. Now let me start this. Okay. Great, that was not too slow. Not too fast, but not too slow. I just took this mouse just in case. Yeah, I think I'm going to have to focus mostly on this. All right, so we're ready to go?
Yeah.
All right, so thanks for coming to my talk. My name is John Lapeyre. I work at IBM Quantum. I mostly work on, well, there's a lot of different things there. I worked on various ones, but right now it's Qiskit, which is a Python-based quantum circuit manipulation software for the most part. It's and I'm going to talk about Qurt, which is a Julia package, which is designed to work closely together with that, hopefully to steal some of the work from it. So I need to say what Qiskit is. It's described on the website as a software development kit for working with quantum computers at a wide variety of levels. So abstract circuits down to pulses that control hardware, things like that. It's pretty large and ambitious. Pieces are added and taken away. The focus changes as scale increases. It has to do a lot of things. Have a way to represent quantum circuits, do I/O, talk with other formats, gates and operations that live, or the things that live on quantum circuits. It has to be able to do a lot of different kinds of those, user-defined as well. And some different kinds of, without going into it, classical computation that happens together with the quantum. And perhaps the largest part is dedicated to transforming one circuit to an equivalent circuit with different gates. This is, like classical compilation. And this could be because you have to have gates that have certain requirements, and so you need to translate to those or optimize the gates according to certain metrics. And then interact with various backends and quantum computing architectures, superconducting circuits, trapped ions, etc. And then there's a lot of computation and calculation. Of course, this would be these are like the linear algebra things. And this is largely to support the compilation. And this is, of course, a natural place for Julia to target. So Qiskit is currently written mostly in pure Python with Numba. There's no Numba currently, Cython, anything like that. For performance and acceleration over the last 2 years, that's coalesced on Rust. And it's important to note that this is not, for instance, there are other projects out there that take a C++ core or a Rust core, brand new one with Rust, and they develop that and then have Python wrappers. But this is not developing that way. There's always pressures on performance, and there's a lot of low-hanging fruit, even for the pure Python that we have, and people are working on that. And also, stuff has always been moved to Rust. So, what is Qurt? It's, I want it to be able to easily do some of the work that Qiskit is doing. Rewriting Qiskit in Julia would be very difficult for a number of reasons. and not the least reason is that Qiskit's a moving target. It would be quite different by the time you got there. And they're changing it quite a bit. So I had originally thought of some tasks. I think the entirety of Qiskit would be well suited what it does to Julia. But I've been looking for parts that were particularly well suited where you could get the biggest dramatic advantage or something. But circuits sort of pervade even the peripheral parts of Qiskit. You always run into circuits right away, which is a data structure, a few data structures actually that represent in different ways. And so, I've tried some other things actually. And Qurt now is, it's the work that I've done so far, which is not a large portion of my time there, is centered on making circuits that are capable to match Qiskit capabilities and to be able to convert. And so writing this efficiently is rather difficult because this was written in Python and people took full advantage of all the, the freedom you have there. And it's very flexible. The circuits are mutable. The data structures around the circuits are mutable. Users can define gates on the fly with very few constraints. You can shove anything into a list. So, you can't make a lot of assumptions about data types and so forth. And I may have to scale back perfect compatibility. So I wanted. There's a lot of emphasis on how am I doing on time? Performance. There's a lot of emphasis on efficiency right now and scaling up that they're trying to do. So I want from the beginning to choose some data structures and algorithms, not to have everything over-optimized to begin with, but of course, to not find that you have to rip something at a deep level out later because it wasn't the right choice. That never actually works completely, but it's a good thing to try. So one of the first things you have to do is decide how to represent gates, and Julia will often reach for the type system for things. So these gates would be these are parameterless gates, hx, I don't know if you can see right now. And this one carries a parameter, this Z rotation gate. But you're going to end up dealing with a container of these. And that means you're going to have to pull them out at runtime and not what they are. And you could have runtime dispatch, which in Julia in particular is very slow. So you have to avoid that. I don't know, it would be nice if there was more discussion or more in the Julia community for ways to deal with this. I think it's something that'll grow naturally, but I made this blocking enums particularly for this this problem. It's a copy. There's other packages like this, a copy of base enums, but I had to add a few things. One is creating instances of this enum after it's been defined, because you have to make a lot of them. You have to allow users to make them. And another is I added named blocks or ranges of integers. So they represent classes of circuit operations. And this is a very crude type system attempt to put some structure into this, but it's the best I can do at the beginning. And then you need to represent the circuit for a lot of the majority of actually difficult tasks you have to do by a directed acyclic graph. And it turns out that the graphs, the main Julia graphs package is sufficient. I had to roll my own metadata because the metadata packages are not sufficient. There's work to be done there. And there was a lot of sort of more or less fundamental, low-level algorithms and things that were missing, and I was concerned about getting some meeting showstoppers and having to do something else with graphs. But I think all of those are taken care of. I put some of these things in another package so they can go into graphs eventually. And then I don't want to say, I guess I kind of ran out of time here, but the data is stored in a structive arrays format to avoid, for efficiency. For instance, these kind of opcodes, you could look at these as opcodes are all stored in a single typed array of a single type. And then, if you're careful, you can have this gate macro, some zero-cost abstractions to allow you to think of the gates grouped together with the data they need, which is the standard way to do it. And I did one benchmark here with a particular reduction of self-inverse gates and found that it's 20 to 30 times faster in Qurt than our Python Rust implementation, which already has quite a bit of Rust in it. And it's also, the code is quite a bit nicer. And then I'll just leave you, since I'm out of time, with a picture of, this looks like a lot of the Python packages and so forth, except it has a nice Julia macro for building. And yeah, I better quit there, so thanks.
Okay, so since we are on to the next speaker, why don't we all save our questions that we definitely have for John. Thank him again for the great talk while Ash sets up. And our next speaker is Ashley Milstead talking about quantum optics.jl.